A simple function is a function that takes on as finitely many values in its range. It means it has a finite set, and you can approximate a given function by simple functions to get the lebesgue integral.
First, you have a simple function that has a condition of a measure space. Conditions such as the measure of an empty set is 0, and the union of the values in a subset, we have it here.
Then we have the domain and range. Let's make an example. Here we have the domain 5, 6, 7, and in the range 10, 11, 12. This is our sigma algebra, and this is our subset. Then we have to sign up here to the function. So when it will be 5, it will be 10, and 6, 11. Also, we have to give a measure to each element of the domain. So when it will be 5, the measure will be 1.
Okay, now what we have to do is to make a graph with all the 3 points. With the domain and the range. The domain is in the x-axis and the range in the y-axis, so you make it. And then to get the lebesgue integral, you need to use this formula. That basically means that you need to multiply the range times the measure of the inverse image of it. In this case, the range 10, its inverse image is 5, and the measure of 5 is 1. So for the lebesgue integral is 10 times 1.
So we have that for f10, the inverse image is going to be 5 and the measure of 5 is 1. So we repeat this process with the other values of the range. So the inverse image of 11 is 6 and the measure of 6 is 2. Then for 12, the inverse image is 7 and the measure of 7 is going to be 3. Now we apply this to the formula. So we have that 10 times the measure of the inverse image of 10 plus 11 times the measure of the inverse image of 11 plus 12 times the measure of the inverse image of 12 is going to be 10 plus 11 times 2 plus 12 times 3, and it's going to be 68. That is the lebesgue integral of this function.
And also the lebesgue integral, you use simple functions to approximate instead of using step functions.
Finally, in the Riemann's integral, you take the base times the height of the rectangles you make, while in the lebesgue integral, you take the measure of the base times the height of the rectangle.
Some of the applications of lebesgue are the use of function spaces, Fourier and transforming in physics and engineering, and probability as it is based on the theory measure.
Conditions such as the measure, its empty as well.
While in the lebesgue integral, you use the measure of the base, while in the lebesgue integral, you use the measure of the base, while in the lebesgue integral, you use the measure of the base,
Engineering and probability as it is based on the theory measure theory.